Hello, my name is Clarissa Guevara. I'm in the 11th grade. I go to Potomac High School, and this is my Stanford project called Fading Skittles. We all love Skittles. Skittles are made up of sugar molecules and then after coated in food coloring and more sugar. When we soak the Skittles in water, that coating of food coloring and sugar dissolves. The purpose of the experiment to test which temperature cold, hot, and temperature water will dissolve the coloring of the Skittles the fastest. The temperature of the water is very important in this experiment because it will determine the final result of that experiment. I can conclude that each different color had different lasting times, but the orange Skittles took the longest for their colors to dissolve. The introduction to my project is water is made of molecules, 2 hydrogen atoms and 1 oxygen. Hot water has more energy than cold water, which indicates that molecules in hot water move faster than molecules in cold water. In my experiment, we will see which temperature water dissolves the coloring of the Skittles. I believe that if Skittles are soaked in hot water, then the coloring of the Skittles will fade faster. The colors of the Skittles will stay the same and the solution is going to change. I hope my prediction is correct. I hope you enjoy my experiment. My hypothesis is I predict that the coloring of the Skittles will dissolve faster in hot water since hot water has more energy than cold and temperature water. When water is heated, the molecules gain energy and thus move faster. My independent variable is type of solution in each cup, which will be water, and my dependable variable is same colors of Skittles. The materials I used was 1 bag of Skittles, 3 plastic cups, cold water, hot water, room temperature water, stopwatch or timer, pencil, and notebook. The procedures I did was prepare all materials, put half of each solution into different cups, put the Skittles in the cup with liquid, time how long it takes for the color to dissolve entirely, observe, record the data, repeat steps 2 more times. This is the data I collected. As you can see, room temperature water took the longest for the color of the Skittles to dissolve, and hot water was dissolved fastest for the coloring of the Skittles to dissolve fastest. As you can see from the slide above, my hypothesis was correct. Hot water indeed dissolved the coloring of the Skittles the fastest. Hot water faded the color of the Skittles the fastest due to the molecules moving faster, making it easier for the color of the Skittles to disappear. The green Skittle was the fastest to dissolve in hot water and temperature water because it's a light color and is not too intense. I am satisfied with my results because it's what I expected. Every color of Skittles dissolved in hot water is in less than 25 seconds, as you can see. This is the pictures I took while I was doing my experiment. In conclusion, as stated again, my hypothesis was correct. I predicted that the cold water was going to liquefy the color of the Skittles the quickest I resolved the molecules in hot water moving rapidly. Hot water has more energy compared to cold and room temperature water. In hot water, the color of the Skittle faded in less than 25 seconds. In cold water, it took 1 minute and less for the color of the Skittles to dissolve. In room temperature water, it took less than 2 minutes in order for the color of the Skittles to liquefy. The coloring of the Skittles you add to the water is pushed around by the water molecules. Since the molecules in warm water move around faster, the coloring spreads out quicker in the warm water than in the cold water. So it made sense for the color of the Skittles to dissolve the fastest in hot water. Future considerations I would take was using other solutions instead of just water. I will also consider using different colorful Skittles to see if they play a part in how fast the colors dissolve. These are my biographies I use in my project. Thank you.